Logic students. Hi, so we're in section 6.4, and I want to demonstrate how to do some of the exercises in this section. We need to be able to do truth tables for arguments. So I picked two exercises from Applia. One is number 4. So you see that the argument, basically here the task is to use a truth table to determine whether this argument is valid or invalid. The truth table can tell you that. And you see that the argument here is listed with the two premises on top, and then there's a bar that indicates that a conclusion is being drawn, and then the conclusion, not G, is written under the bar. When you do a truth table for the argument, you arrange the argument on just one line, like here. This is the first premise. Then you use a single slash to separate the first premise from the second premise. And then once you've listed all the premises, in this case 2, you use a double slash to separate the conclusion. These slashes have no logical significance. You won't put anything under the slashes here. It's just a way to keep things separate and neat. So here you have your argument, you arrange it on one line, and then you go through the standard procedure that we have learned already. You first figure out how many rows there will be. So you have two letter types, G and M, so you're going to have 4 rows. That's something you can do here. You can just number them 1, 2, 3, and 4. And then you construct the truth table the way you would for a truth table for a single statement. So you split the 4 for the first letter. True, true, false, and false. And again, for all the G's, you'll be doing the same. True, true, false, and false. And for this G as well. And for the M, you split the pattern again. So just simply TF, TF. And you'll be doing it again here, of course. Okay, and then you start computing. Normally, what you want to do is take care of the negations that apply directly to a letter. So this TTFF with not G becomes FFTT. And the same here. Then remember that once you've processed the negation, that is the column that is relevant. So this you can, you can forget about. It's not relevant anymore. To compute the value of M or not G, you look under the M and you look under the not. This is a disjunction, true and false. It's true, both false, false, both true, true, one false, one true, true. So now you have a column under the main logical operator for this second premise. Over here, first you have to compute inside the parentheses, and then you're going to reverse that with the tilde that is outside and acts as the main logical operator. So both true with and true, otherwise false. This is just a basic truth table for conjunction, but this tilde out here reverses the values that are under the dot. So outside you're going to have F, T, T, T. The truth table is complete. Now you need to analyze it to find out whether this is a valid argument or not. And the rule is very simple. It is an invalid argument, so it's a bad argument, it's an invalid argument, if you can find a row where the premises are all true and the conclusion is false. And so you'll be looking under the main operator of the first premise, the main operator of the second premise, and the main operator of the conclusion. And you go line by line. You look here, here, and here, and see if there's a line where you have a T under the operator, the main operator of the first premise, a T under the main operator of the second premise, and then F under the main operator of the second, oh, I'm sorry, of the conclusion. Okay. If you don't find that line, that means the argument is valid. So we're looking for TTF on a certain line. Let's see. You don't have it here because the first one is false. So you can, this is not TTF. And this one is T, but this one is F. And even if the conclusion is false, the two premises are not both true. And then obviously the two last lines are irrelevant because the conclusion is not false. You're looking for a line where the premises are all true and the conclusion is false. So obviously the last two couldn't be. So there's no line in this table where all the premises are true and the conclusion is false. So it's a valid argument. Okay, let's try another exercise real quick. This is also from Aplia. It's number 7 down here. The structure is the same, 2 types of letters, so 4 rows, 1, 2, 3, 4, and then you do the usual setup for W. You go T, T, F, F. Now let's find all the W's. T, T, F, F, another W here. And for X, we're going to do TF, TF. And then we start computing the usual thing. First you process the negations. So this TF, TF will become FT, FT. And this TT, FF will become F, F, T, T. And now we can start in this parenthesis. Remember, you look under the W and under the tilde here. And you use the truth table for the dot. True and false, false. Both true, true. False and false. Now remember, the tilde outside reverses the column under the dot. So false. So false becomes true. True becomes false. False becomes true. And false becomes true. Okay, you see that they differ. False becomes true, true becomes false, and then the two falses become true. Over here, true and false with the conjunction, false, false and false, false, both true, true, false and true, false. And then you reverse, the false becomes true, this false becomes true, true becomes false, and false becomes true. Over here should be very quick. True, 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 and false. That's a basic truth table for disjunction. Okay, so this is complete. You have to look under the main operators. So this is the main operator. This is the main operator for the second premise, and this is the main operator for the conclusion. Can we find the line where you would have a T here, a T here, and an F here? So doesn't work for the first line, T, T, and T. Second line has a false premise, so I can have all true premises and a false conclusion. The third line has a true conclusion, so you couldn't have all true premises and a false conclusion. Let's look at the fourth line. The first premise is true. Whoops, sorry. The second premise is true. And the conclusion is false. Okay, so there is a line where all the premises are true and the conclusion is false. This means that the argument is invalid. I hope this helps. It's kind of a longer video, but I hope it's useful. and let me know if you have any questions. Thanks.